Good evening and welcome to Students Dominate Math. My name is Eric Hendricks and I am a math teacher at Providence St. Mel School. And what we have for you for the next half an hour is a show that what we want to do is serve as your math tutor. This is a live call-in interactive show brought to you through the facilities of KNTV. So what we want to do is have you call in. The number here is 312-738-1060. And this show is designed to assist students in performing well in school. This show is designed to assist students in performing well in specifically their math classes. So I, for the next half an hour, want to be your math tutor. You can ask me questions about whatever questions you have in the area of math, from algebra to calculus. I can do the best that I can to assist you in whatever questions you have. If you don't call in, what I typically do is I'll have a subject in mind, a subject that I want to talk about. And until you call in, we'll talk about the subject that I want to talk about. If you call in, I'll stop what I'm doing and I'll answer whatever questions you have. So you can call in right now. Again, the number is 312-738-1060. And like I say, I'll stop what I'm doing to address whatever questions you have. It might be a test you have coming up. The high school students, they have their final exams coming up. And there might be a topic that has always caused you difficulty. But we can end those challenges right now. You can call in and I'll do the very best that I can to answer your questions. You might have a homework assignment that's due tomorrow. You might have a homework assignment that's due tomorrow, and what I can do is help you with the homework assignment. I can guide you through it, give you tips and strategies to assist you on that assignment. All right, so until you call in, what I'll do is I'll talk about a topic that our students are addressing right now. Our students are talking about this right now. So I'd like you to think back. I'd like you to think back when you were a little student, and one of the things your teachers had to do is teach you how the value of numbers. Your teacher had to discuss with you the values of numbers. And let's just talk about that for a minute. We'll connect it to something called binary numbers. Okay, that's what we're going to talk about today. Different types of number types, specifically what are called binary numbers. All right, so here we go. Let's move this off. We're going to talk about this. We're going to talk about this circuit as to how it relates to binary numbers. Okay, we're going to talk about that later. But let's push this to the side for a moment. Let's push that to the side. And let's say we have the number. When you were little, your teacher had maybe a 5. All right, your teacher maybe had a 5. Or better yet, let's say a 2 next to a 3. All right. When you were little, your teacher had a 2 next to a 3. Now, if you think about it, when you were little, you knew what a 2 was. When you were little, you knew what a 3 was. You knew what a 3 was. But then your teacher started talking about a 2 next to a 3. Now, as a little person, again, you knew what 2 apples were. You knew what 3 apples were. But when your teacher started putting the numbers together, possibly, you said, whoa, wait a minute. I was with you when we had 2 apples. I was with you when we had 3 apples. Well, what is this 2 next to a 3? How are we supposed to interpret that? Okay? So what your teacher had to do is your teacher had to talk to you about what a 3 in that place means. What does a 2 in that place mean? Well, then your teacher had to talk about the units place, the units place and the tens place. The units place and the tens place. All right? And then what your teacher had to communicate to you was the units place. The units place, when you had a 3 in the units place, you were looking at three individual items. And when you were talking about a 2 in the tens place, you were looking at 2 sets of 10. And I'll draw that right now. 1, 2, 3, 4, 5, 6. Oh, running out of space. 7, 8, 9, 10. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's a 2 in the tens place. So let's have another set of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so now your teacher was trying to show you what a 2 next to a 3 meant. Well, when you're in the 3 is in the units place, you want three blocks where each block is 1 unit. But here, when the 2 is in the tens place, this 2 represents 2 groups of 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now, as a little person, you can now count all of these blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23. And now, as a student, you have an idea of what a 2 next to a 3 means. You have an idea of what a 2 next to a 3 means. Now, why are we even bringing this up? The reason I'm bringing this up is because every number that we work with, every number that students work with, is what you call a base 10 number. 23 is a base 10 number. So let's show you, mathematically speaking, how we got the value of 23. Let's show you how we got the value of 23. 23 is a base 10 number. So you got the 2 next to the 3. This 3 is to be interpreted 3 times 10 to the 0. And then this 2 is to be interpreted 2 times 10, not to the 0, but 10 to the 1. All right, 10 to the 1. So now what we have is we have 3, 10 to the 0, if you know your exponential properties, that's 1. And then this is 2 times 10. So you get 20 plus 3, and then you get the value of what you're working with. In other words, the number of blocks represented by a 2 next to a 3, you get 23. If this were a number here, if there wasn't, but if there were a number here, that would be, you would add 3 times 10 to the 2. In other words, the hundreds place. The hundreds place. If there were 3 in that third position here, you take 3 times 10 to the second. And you add everything up to get a value of what these numbers side by side represent. Okay? So now what we're going to do is we're going to talk about an entirely different number system. We're going to talk everything that you're used to, every number that you're used to working with has always been written in base 10. A 2 next to a 3 is in base 10. A 3 next to a 4, the number 34, that's been written as a base 10 number. Let's talk about some numbers that are not base 10, but are in base 2. Anytime you have numbers in base 2, they're called binary numbers. All right, they're called binary numbers. Okay, so let's take a look. All right, so some examples of some base 10 numbers, some base 10 numbers that you're used to. Base 10 numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all base 10 numbers. All right, those are all base 10 numbers. But let's talk about some base 2 numbers, some binary numbers. Base 2 numbers. Now, when you had base 10 numbers, numbers that are in base 10, the only numbers that you had at your disposal were 0 to 9. You only had 10 digits at your disposal. You only had 10 digits at your disposal. Base 10 numbers, you only have 10 digits at your disposal. You have 0, 1, 2, 3. You only had, let me show you here. When you have base 10 numbers, you only had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You only had 10 numbers. You only had 10 numbers at your disposal. Well, a base 2 number, you only have 2 numbers. You only have 2 numbers at your disposal. Those 2 numbers are 0 and 1. Those are the only numbers that you can use to identify any number when you're talking about a binary number, base 2 number. And let's just write them out for you here. All right, so let's sort of organize our work here, and we will get started. All right, so we're talking about binary numbers, base 2 numbers. We'll even show you to some degree how this can be used indirectly. All right, so let's set up a little system here. We got 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Let's go 0, 0, 1, 1, 0, 0, 1, 1, 0, 0. Let's say we got 0, 0, 0, 0, 1, 1, 1, 1, 0, 0. And then we go 0, 2, 3, 4, 5, 6, 7, 8, 1. All right, so here are some examples of binary numbers. All of just 0 is 0, but a 0, 0, 0, 1, that is how you would identify the number 1 in base 10. A 0, 0, 1, 0, that's how you would acknowledge the number 2. But this is a binary number. This is a base 10 number or decimal number. But they're equal to the same thing. This is the number 3. 0, 0, 1, 1. That's how you'd identify the number 3. All right. Now let's do the same thing. I'm not going to go through all these, but this is 9, this is 8, and so forth. All right. So let's show you what you would do if given the number. I'm looking at this number here. I want to show you that this number here is 7. All right. So let's write down the number 0, 1, 1, 1. 0, 1, 1, 1. All right. So let's write that over here. All right. So we got 0, 1, 1, 1. Now, when we were testing the number 2, 3, in base 10, we said this number times 10 to the 1, because it's a base 10 number, and this number 3 times 10 to the 0. All right. When you were little, your teacher called that the units place and the tens place. Now we're working with a base 2 number or binary number. So this number is in the 2 to the 0 place. This number is in the 2 to the 1 place. This number is in the 2 to the 2nd place. And this number is in the 2 to the 3rd place. All right. just like this was in the 10 to the 0, this was in the 10 to the 1, this is in the 2 to the 0, this is in the 2 to the 1, 2 to the 2, 2 to the 3, and however long this binary number would be, you would extend the value of each individual place. So, in the same way we took 3 times 10 to the 0 and 2 times 10 to the 1, we're going to take 1 times 2 to the 0, add that to this 1 times 2 to the 1, and add that to this number 1 times 2 to the second. All right, and you end up with, this is 2 to the 0 is 1. You end up with 1 times 1, which is 1. Add it to 1 times 2 to the 1, that's 1 times 2, which is 2. And then this is 1, 2 to the second, that's 4. And you end up with 1 times 4, which is 4. So you end up with 4 plus 2 plus 1. I'm sorry. I'm very sorry. 4 plus 2 plus 1, which is 7. So 0, 1, 1, 1, 0, 1, 1, 1 is the number 7. All right? The last thing I want to show you, about this idea of binary numbers is you can convert from the 7 also to the binary number. You can not only convert from the binary number 0, 1, 1, 1 to get a 7, but you can also start with a 7 and end up with the binary number. All right, so let's show you that, and then we'll show you some applications to this, and then we'll be out. Okay, so let's start with a 7. Let's start with a 7, and you want to convert this to a binary number. You divide by the base that you want to convert this to. All right, so we want this to be base 2. You divide 2 into the 7, you get a 3 remainder 1. 3 remainder 1. Then you take that quotient 2, that quotient 3, and you divide by the base again. All right, and you divide that by 3. You ended up with the quotient of 3, and that's what you divide by again. You get a 1, another remainder 1. All right, and then you take the 2, divide that by the quotient here, by the quotient that we got 1, you get 0. You get 0, and that is a remainder 1. Okay, and then you end up with 2 into 3. 2 into 7 was 3, remainder 1. You end up 2 into 3. You get 1. That's again remainder 1. And then you go 2 into 1. You get 0, remainder 1. All right. So then what you're going to do is take this problem from the bottom up to the top. Okay, from the bottom up to the top, and again you notice you get 1, 1, 1. Okay, you get 1, 1, 1, which is the same thing that we got here. 1, 1, 1. All right, and that is just a way in which I'm just trying to show you how you can go from 0, 1, 1, 1 to get 7, and then how you could have also given the number 7. You start with the number 7, you convert the number 7 to a binary number. All right, now what does this have to do with anything? We only have 5 minutes left. So let's just show you how maybe we can pick this up next week. But one of the things that our students are doing is they're working with electrical circuits. And we'll pick this up next week, but you don't necessarily work with binary numbers with electrical circuits, but with electrical circuits what you'll do is you'll have leads to this, what's called an integrated circuit. You'll have two, we'll pick this up next time. We'll have leads to an integrated circuit, and when you power when you power an integrated circuit, putting power to it, we would liken that to using the number 1. If you put power to this lead on a circuit, we would liken that to be the number 1. Well, then if you take the power off of the circuit, we'll do this kind of thing next week, but when you move this lead till you take the power off the circuit, that we would liken that to being a 0. If you're adding power to the circuit, that's a 1. If you take the power off the circuit, that is 0. And then there are certain things that are happening when you put the power on or put the power off, depending on what kind of integrated circuit you have. Depending on what kind of integrated circuit you have, you putting power on or off will impact what this LED does, what this light does. Okay, but we'll talk about that kind of thing. We'll talk about that kind of thing next week. Speaking of next week, and we only have a couple minutes left, to all the parents out there, I want to encourage parents to purchase gifts for the children that are more educational. They got plenty of clothes. They have plenty of shoes. Parents, they have plenty of games. Parents, oh my goodness, parents, they have enough videos. They have enough, what do they call those video games? They got enough of those. Purchase things for them that will really stimulate their mind. It's called a breadboard. You go to the internet, you learn what the students can do with breadboards. It teaches them the basics of circuitry and electricity. It won't hurt them. This is a very, very low voltage. It won't hurt them. But I was working with some students just today, and they were crowded around the breadboard, and they were excited about it. And they weren't even realizing that they are learning. It's beautiful. So go to Radio Shack, someplace like that. I'm not making any money off this, but the students will grow and learn about electricity. It might inspire them to want to grow up and become an engineer or something like that. Another thing I want to show you, we only have a couple minutes left. This is Lego. This is Lego, okay? Lego makes things that help students. They learn about robots. They learn about robots, and they can do programming. They build the robots. They actually, it didn't come like this. They have to build it. They have to build it, and then after building it, what the students have to do is they have to do programming. They have to program the robot and tell the robot to go right. You tell the robot to go left, and the robot does what the child. This is designed. It's created for like a 4th grader, a 3rd grader. Okay, so we've got to go. That's all we have time for. Maybe we can pick up on some of this stuff next week. God bless you. Thank you for watching. This is Students Dominate Math every Thursday at 5:30. Thank you for watching. Have a good evening.